Okay, hello students. This is a video about geometric sequences. Now we have been learning about arithmetic sequences, and we know that arithmetic sequences, in those types of sequences, each term is found by a common difference. If you add something to the first term, you can get to the next term. So you could add something or you could subtract something. Either way, there's a common difference. Well, with today's series, we're talking about geometric series, and each term is found by a common ratio. So now, to go from one term to the next term, you have to multiply by something. Multiply by something, that something being the common ratio. So, for example, if I have a sequence like this, 2, 4, 6, 8, okay, 16, how can I tell that it's geometric? What is the common ratio? In order to find the common ratio, we take any two terms in the sequence and we're going to divide them. So if we do 4 divided by 2, 4 divided by 2, or if we do 8 divided by 4, or if we do 16 divided by 8, okay, we take two consecutive terms, it has to be consecutive terms in the sequence, and we divide them. We get the common ratio R, and all of them are the same. The ratio in this case is 2. Okay, now the formula for determining geometric sequences is like this. The general case for the geometric sequence, Tn, is equal to Ti, that's the first term in the sequence, times the ratio R to the power of n minus 1. So in this formula, Tn is the nth term, T1 is the first term, R is the ratio, and n is the number in the sequence, such as is it the first term in the sequence, the second term in the sequence, and so forth. Okay, so is this formula geometric? Can we write the formula for that sequence? Okay, in order to tell if it's geometric, what we can do is divide two of the terms. So if we divide two of the terms, we can figure out what R is. Okay? So if we divide two of the terms, we get negative 8 divided by negative 4, which is negative 2. So if I multiply by negative 2 each time in this sequence, do I get the next term in the sequence? 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. 16 times negative 2 is negative 32. So it looks like my ratio is in fact negative 2. Since there's a common ratio, I know that it is geometric. So I can write the formula for this sequence like this. The first term in the sequence is 4. That's my Ti. And then let's use parentheses to separate the multiplication here. Okay, I'm going to have negative 2, which is my ratio. And the negative 2 is raised to the power of n minus 1. So here is a general formula for this particular sequence. Okay, let's change. Okay, let's see if we can find the fifth term of the sequence if we know that the first term is 8 and that the sequence follows this pattern, 3 times t to the t of n minus 1. So what that tells us is that the first term of the sequence is 8. To find the next term of the sequence, we multiply 3 times. This n minus 1 tells us that it's the previous term in the sequence. This n minus 1 is the previous. So we have 3 times the previous term, and the previous term is 8. Okay, so that gives us 24. Now to find the next term in the sequence, we take the term from the previous one, which was 3 times the previous term. So now we have 3 times the previous term, and the previous term is 24. Okay, and 3 times 24 gives us 72. Now, since I'm only asking for the fifth term in the sequence, you really could just keep going, right? Multiplying by 3 and coming up with the next term. But I'm going to use the formula. So I can see that what would my ratio R be that I'm multiplying by each time? If I take two terms in the sequence, the second term and the first term, and divide them, I can find out what R is. Okay. It looks like my common ratio is 3. Okay, and n. N is the number of term in the sequence. I'm looking for the fifth term, so I'm going to use n to be 5. And then ti is my first term in the sequence, and the first term is 8. So now that I have all the values, I can plug into the formula to find the fifth term. So t of 5 equals the first term. The first term, ti, is 8, isn't it? Times the common ratio, which is 3. And 3 is raised to the power of n minus 1. That's going to be 5 minus 1. So we have 8 times 3 to the 4. Okay, and 8 times 3 to the 4, I can use my calculator for that, and I get 648. Okay, great. We can also find the sum of an infinite series for a geometric series. So what happens if we add together all the terms of the sequence? What value do we get? Well, we can get a specific value if the common ratio is a decimal, is like a fraction, anything between 1, anything less than 1, more than negative 1. So if the value of the ratio that we're multiplying by is a fraction, okay, or a decimal, positive or negative, then we're going to get an actual answer for the sum of the series. It's going to converge to a number. However, if the ratio that we're multiplying by r is greater than 1, then the series is going to diverge to infinity, which means that as you add up all the numbers, you keep adding and adding and adding, the number that you're adding to for the sum of the series is just getting bigger and bigger and bigger, but it's never actually coming to a number. It's going towards infinity. And if the number that we're multiplying by, if the common ratio is a negative number, anything less than negative 1, then the series is going to also diverge, and then it would diverge to negative infinity. All right, but this is the formula you need to know for the sum of a geometric series. All right, and let's go ahead and do an example of finding the sum of a series. For the first for the first series, we have 4 over 25 plus 2 over 5 plus 1, continuing on. In order to find the sum of the series, we first need to define what the ratio r is. So let's divide 2 of the terms to find the ratio. Okay, and when we divide that out, that reduces to 5 over 2, which is 2.5. So since the number we got for r is a number that's greater than 1, this does not have a sum. It is going to diverge. And it's going to diverge, so diverges. Okay, the sum does not exist. Sum does not exist. Diverges to positive infinity. All right, so that one didn't end up being that spectacular, but let's try another one. What is the sum of this sequence? So let's divide 2 of its terms to find the ratio for this sequence. Okay, so here we have the r is the value 1/3, negative 1/3. So because this is a fraction, a number between negative 1 and positive 1, it looks like we are going to have an actual answer. So let's go ahead and plug into our formula. We know the sum of the series is 1 over 1 minus r, so 1 minus 1/3, minus negative 1/3 turns to plus 1/3, and then we multiply by the first thing in the sequence, which is 18. All right, so when we evaluate that, we get 18 times 3/4, okay, which is 27 over 2. So the sum of this series is 27 over 2. All right, great.